So today we're going to talk a little bit about the Microsoft Visual C++ standard template library. It's shipped with every version of Visual Studio and is what makes the C++. So very briefly, what I want everyone to walk away from this presentation with is a basic understanding of the C++ STL regardless of C++ experience or STL experience or programming experience in general. Why you should always use the standard template library in C++ code and why it's considered bad practice to avoid it. We're going to talk a little bit about the performance guarantees that the standard template library offers. And this is not really an intro to C++, but I want to give everyone a glimpse of what the power of C++ is and some of the capabilities that it has through things like templates and the standard template library. Hopefully, everyone can get some information out of this regardless of programming experience, as we'll talk about some general stuff as well as some more specific examples. And we're also going to talk about why C++ is the most used language in competitive programming. Now, before I get started, I want to bring up someone by the name of Branimir Karzadek, and he advocates for something called orthodox C++, which is essentially C++, but without the standard template library. So it's essentially just C with some C++ features. C++ is kind of in an interesting situation when it comes to programming languages because it's a superset of C, meaning that basically every C program is a valid C++ program, and this causes some C developers to use C++ without some of the more powerful C++ features that really makes the language what it is. And this way of thinking about C++ says that any C developer should be able to understand C++ code. So he advocates that you don't use any STL features because it is not necessary and it just overcomplicates things. By the end of this presentation, I hope that everyone can hopefully poke some holes in this argument, as I believe it to not be the best way of looking at C++ because of how powerful the standard template library is and how it allows for readability in your programs. So first of all, I've been saying STL and standard template library, but what is that? So C++ is an extremely powerful language specifically for making libraries. So introduced in some time ago, I believe it was C++ 10 or something. We're on like 20 now. Templates were introduced, and a template means that you only need to know the type of a variable at compile time, meaning that you can write these massive libraries with various containers and algorithms, and they don't actually care about the types that they're working with. And this is really what enables the standard template library to be what it is this idea of templates. So in C++, you can make your own very specific version of C++, your own flavor. And this is done a lot in competitive programming where you have this massive library of really specific stuff, and it allows you to write C++ in a way that only you can understand because of how unique it is. So the first thing about the standard template library is that it's a library, not a framework. And what I mean by that is the standard template library doesn't give you anything that you can just run by itself. Something like a framework would be, for example, OpenGL, which is a C++ graphics rendering library. And what that allows you to do is create a window class and instantiate it right then and there, and boom, you have a window on your screen open. Standard template library doesn't provide you with anything like that. All of the code that you want to run has to be written by you. The standard template library just provides you with a means for improving the runtime of your code, the space complexity of your code, and the readability of your code. So why use the standard template library? We talked a little bit about orthodox C++ and why I believe it to be an incorrect way of looking at the language, but why should you actually use it? So the standard template library provides high standard performance and space complexity guarantees that are just not really possible to maintain by yourself. The standard template library, especially the Microsoft's implementation of it, has been developed by years by the same people that spend all day of their time staring at code, trying to make it run faster. And there's just no way that you can match the performance of the standard template library like these massive developing teams can. So a lot of higher level languages like Python do a lot of this work behind the scenes where you can increase the size of a array or decrease it, or in Python, the term would be list. But C by itself really can't do any of that because it's quite a low level language. You have to allocate all the memory yourself. But C++ is kind of in this middle ground where you can have a container that can allocate its own memory from the standard template library, and you can write C++ code more like a higher level language like Python, while also having all of the control of a lower level language. And this is something that the STL will provide you and is what makes it so powerful. So to talk about the basic structure of the standard template library, there's two things contained within it. There's containers and algorithms. We're going to talk a little bit about the standard vector container today, and if we have time, we'll talk about the standard sort algorithm. Now, the important thing about this is that the containers and algorithms do not know anything about each other, nor do they care about anything about each other. A container does not care what an algorithm will do with it, nor does it understand what it's doing with it. All the container will provide the algorithm with is the pointer to the very first item in the container and the very last item, and the algorithm will do everything else. Now, the algorithm also doesn't know anything about the container. It doesn't know if it can dynamically resize, but all it needs is the pointer to the first item and the pointer to the last item, and a way to access and write information. If you want to write a separate implementation for every container in the standard template library, you run into this problem of n times n containers for algorithms, where every single container has its own implementation of a standard algorithm, and every algorithm has to be implemented in each container. And you run into this problem where you have massive varying implementations of containers and algorithms, which is just not sustainable at all. So containers and algorithms in the STL talk to each other through pointers and iterators. For the sake of this presentation today, I'm going to be calling everything pointers, even though that's not technically correct, but we're not going to worry about the difference for now. And this keeps the n times n algorithms for containers down so that we can have the algorithms and containers separated so they don't need to know anything about each other. So as long as there's nothing up until this point that I've mentioned that anyone has a question with, I would like to get into some very basic examples now. And we'll kind of walk through some standard containers and some standard algorithms.
Yes, I think we can continue. If there is question, I will let you know.
Perfect. Okay.
Yeah.
So the very first thing that I want to talk about is standard vector. Now, vector is the standard container in the C++ STL, and we really want to use it for almost everything that we can. The main reason for this is because it's a linear container, meaning everything is stored in a straight line in memory, which I will get into more in a minute. And it also has the capability to resize itself so that it doesn't need to know how many elements are in it in order to function. So something like a C array when you create a C array, you have to tell the compiler exactly how many memory spots need to be allocated for this type, and you cannot change it at all. Unless, of course, you create some sort of a struct, excuse me, unless you create some sort of a struct that allows for dynamic resizing, although with C being a functional language, writing something like that can be extremely difficult. So to start off, we're going to talk about pushback for the standard vector. Now, pushback just simply adds an element to the end of the vector, and if it needs to, it will dynamically resize the vector to a new size. So what I've just done is instantiated a standard vector container of type integer. This is the syntax for templates. So the vector doesn't care what type it is until compile time. So I'm telling the compiler right now that this vector holds type of integer. I could write anything in here. I could write a Boolean value. I could write float. I could even write another vector. But for now, I'm just going to leave this as integer. And here, all I'm doing is adding a value to the end of the vector. So when I create this vector, it has no size and no elements. After line 7, I've added 1 to the vector. After line 8, I've added 2, so on and so forth. Now, when we create this vector, it has no size and no elements. And when I call pushback, the vector has to enlarge itself to allow for more elements. So if we can think about it like this. So when I create a vector, it has no space allocated to it. So it is completely empty. We would write that with this kind of syntax. This represents all of the elements that are stored inside the standard vector. And pointers, which I'm going to talk about in a little bit, are inclusive exclusive. So the first pointer represents the first element in the array, and the end pointer represents one past the last element in the array. The reason for this is because if we have no size, like we have here, first would represent this point and last would represent this point. And if we didn't do this, both pointers would point to the exact same address in memory if the vector had no size. And we run into some interesting problems when we do this. So to avoid this entirely, we say inclusive exclusive, first points to the first element, last points to one past the last element. So after I call all these pushbacks, our array looks something like this. I apologize for not writing the correct syntax. So now our vector has size 3. But how did it actually do that? Because when I called pushback here, the size was 0 and it had no memory allocated to it. And after this line, it should have had one size. And after this line here, it would have had to resize again. But I talked a little bit about certain performance guarantees, and one of those guarantees of the standard library is that vector has linear complexity when expanding itself. And it has an interesting trick that allows it to do this. So after line 7, the vector decides that it needs some amount of memory allocated to it. So for the sake of argument, let's just say it allocated 1 bit and put a 1 in here. That is a really derpy 1, but we're going to go with it. And it put a 1 in here. But then, once it reached line 8, it realized it didn't have enough memory to store the next bit of information. So what it did is it reallocated another set of bits, this time slightly longer, and it moved everything that was previously stored into this new set of memory, and then it deallocated all of this memory. So it freed all this memory, and now it owns a new set of memory, and this allowed it to keep this 2 in. But there's also an extra cell here. Why did I draw that? It's only adding one piece of information. Well, that's the trick that the vector applies to itself to allow for a linear time guarantee when expanding the vector. It will expand slightly more than it needs to. In some cases, it will expand significantly more than it needs to. And it does this so that if you're adding a huge number of elements, it only needs to do this once every 1/2 n times. And essentially what that means is it'll slowly start expanding itself more and more as the vector gets larger and larger to keep this guarantee reasonable. Because let's say I was adding 10,000 elements to this vector. If it had to move all of its elements and reallocate memory every single time that I called pushback on it, it would run ridiculously slow, and that's just not a reasonable thing to do. So the vector will expand itself more than it needs to in order to keep this linear guarantee reasonable. So then as we get to line 9, it will check to see if it has enough memory to add the last bit of information, and it indeed does. So that's a little bit about pushback, and I hope that made some resemblance of sense. Now I want to talk a little bit about first and last pointers. So if we redraw the bits that we had, actually, let's try this slightly differently. So I talked a little bit about inclusive exclusive, where first points to the first element and last points to one past the last element. And I'm going to talk a little bit about that now. So if you're an avid C developer, you'll start to realize that there may be a problem with what we're doing here, where in C, there's no way to access how large an array is. When you create it, it is that size, and you better store what that size is somewhere. Otherwise, you'll never be able to loop over the entire thing because you have no idea how long it is. Now, in C++, when we start dynamically resizing things, how do we ever know how big something is or how much memory it has? Now, vector will store size, so you can call dot size on a vector, and it will return to you the number of elements that it has stored. But it also has first and last, or sorry, first and end. So first will point to this one here, and end will point to an extra piece of memory outside of the range of stored values. And I mentioned before why it does this. If we have a vector that has no elements stored in it, and it was inclusive, both first and end would point to the same address in memory, and that would be really bad. So we do inclusive exclusive, where end will point to one past the last element that is stored, even if no elements are stored at all. So let's write that. Let's loop over all of these values. So first, I want to get the pointer to the first number in the array. Let's call this first. So begin will return the address in memory to the very first thing stored in the array. And end will return the one past the last element. So if we were looking at this from top to bottom, end would return here, even though all the values are here. So to loop over all of them, I would do something like this. So while first does not equal last, increment first. And again, I said that hopefully you would gain some information out of this regardless of your programming or C++ experience. So this part of the example is not part of something that I'm going to talk about. I'm not going to really talk about the syntax here, but hopefully I can get my point across without everyone understanding exactly what's happening here. So if I print out first, and essentially all I'm doing here is first is a pointer, and to get the value that's at that pointer, I have to add this star here. And hopefully we're going to get 1, 2, 3. Perfect. Now that's a little bit about the standard vector. Excuse me. That's a little bit about standard vector. I hope at least some of that made some resemblance of sense. The main things to take away is that vector can be dynamically resized, and we can access the information that's stored in it using pointers. Now, we can also write this in a slightly different syntax, more similar to how you would write a loop over an array in C. So instead of using pointers, we can actually use the size of the vector. So we can start with a standard integer of I that is 0, and we can say while I is less than v.size. So v.size is going to return to us the number of elements that are stored. And using this sort of syntax, which will look a lot more similar to C developers, we can access all the pieces of information in the array. Now, this is slightly less useful than pointers, and we'll talk about why when we get into sorting, but it's actually really efficient to know the exact address of memory of the starting and ending point in an array, and in this case, vector. So if there's no questions about something like this, I will move on to some algorithm examples. We'll talk about standard sort and what the STL guarantees for sort. And then hopefully we'll wrap everything up. We'll talk a little bit about orthodox C++ again. I'll answer some questions, and then we'll get all of you on your way with your Sunday morning. Okay, in that case, I will be moving on. Now, I didn't mention it before, but lines 1 and 2 are including things about the STL. Now, IOStream is the standard output library. It's not even really a library. It's something that every C++ compiler has. It's just the way you input and output things in C++. It's responsible for this, and it's responsible for the console output that I was writing in the middle of the for loop. Vector is part of the standard template library. It's included also in every C++ compiler. Every C++ compiler has access to the standard template library, or at least some implementation of it. Obviously, in this case, I'm in Visual Studio, which means I'm using the Microsoft implementation. But now we're going to talk a little bit about sort, which is an algorithm. So now I need to include the algorithm header. This is something that a lot of people complain about when they start using C++ for the very first time after transferring from something like Python, because Python doesn't require you to import stuff like this. All the standard stuff that's in Python is all there. It's ready to be used. You don't need to import things to get standard output or the standard list container or sort. In C++, you do. Some reasons for that is compile time, because C++ is strictly a compiled language. There's certain things to be said about reducing compile time. Python is both compiled and interpreted, so there's an argument to be made that it's okay. Excuse me. There's an argument to be made that it's okay to take the hit of the cost of certain compile and interpreting costs. Python is also a significantly high-level language than C++, and you're sacrificing a lot of performance for making things really easy. So to get started with a standard sort, I'm again going to use vector as it's the standard STL container. If you don't know what container to use vector. There's no reason that you shouldn't. There's no extra performance cost. If anything, it's the most efficient as it's the most used container, so everything in it is extremely consistent. And I'm going to immediately assign it 10 values that are not sorted. It goes 10, 1, 9, 2, 8, 3, 7, 4, 6, 5. And I'm going to sort them. And I'm going to do it two different ways if we have time. So the first way is I'm going to give sort the pointer to first and last. So like we did just before, standard sort wants the pointer to the first and pointer to the last element, or in this case, pointer to one more past the last element. So v dot begin and e dot end. And with this information, the standard template library will look at all 10 elements stored, and it will sort them. Now, this is pretty standard, and there's not really much to say about this since we've already gone over pointers, but the standard sort provides an extremely strict performance guarantee, which is worst case n log n time complexity. Now, to talk a lot about the C++ standard template library, you have to talk a little bit about performance guarantees and time complexity. And I talked a little bit about it before, but essentially, n represents the size of the elements that you're working with. So in this case, n is 10, and at most, this sort algorithm in the worst case scenario will use n log n operations, so 10 log 10 operations in the worst case. In the best case, it will become linear, meaning that it will use at most n operations, but that's pretty inconsistent and not at all repeatable. So in general, the fastest that you can sort any range of objects is n log n operations, or n log n comparisons, meaning is this thing smaller or bigger than this thing? And that's what standard sort will do. There's also other implementations of a sort that you can do in C++. For example, stable sort. If you have two items that are the same, but they have extra information that is stored in them, like for instance, if it's a class that has the age of two people and the name of two people, and you have a list and you want to sort that list, but if they're the same, you don't want to risk swapping them, in the array, you would call stable sort, which takes some extra time to avoid doing this, but also provides a similar performance guarantee. Now, this is important when talking about why you should use the STL, because it is completely unrealistic to expect anyone to implement a sorting algorithm by themselves that would in any way be close to the performance that you can get out of the standard template library with the teams of people behind it that are updating it every single day. And because of that, it's just silly to say that it's bad practice to use the STL when it is so incredibly powerful. But we'll come back to that in a minute. So we've, at this point, sorted our standard vector, and we want to extract all the information from it. I'm going to use a similar syntax that I used before, although this time, instead of creating the pointers outside of the for loop, I'm going to put them directly in. It's common to write this syntax as this. So instead of I, we're going to use it short for iterator. I have been referring to everything as pointers, but technically v.begin, v.end return iterators. But iterators have slightly more complexity because they don't necessarily point to one thing after the other. They can point to technically any address in memory if you increment it, but a pointer, if you increment it, it's just going to give you the next thing in a linear fashion. A little bit about the auto keyword that I'm using here. v.begin is going to return a vector int iterator, which is quite a long thing to type. So in general, we just use auto. Auto will assume the type at compile time. In general, we don't really care about it as a developer. We don't care what type it is. We know that it's going to be an iterator, and any type of iterator, if statically typed, is going to look really weird, so we just use auto. There's nothing wrong with using auto. There's also nothing wrong with writing out the whole thing, but I'm not going to be doing that. So as you can see, our array went from 10, 1, 9, 2, 8, 3, 4, 3, 7, 4, 6, 5 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is exactly what we would have predicted. There's ways that we can test the time that it took and the number of operations. But unfortunately, we don't have time to go through all of that today. So this is all I'm going to do for sort today. And we could talk a lot about other features of the STL, like smart pointers or for loops or is sorted. And there's quite a lot that you could talk about in just this header. And there's also quite a lot that we could talk about in many other different headers. The main point being is that the STL is what makes C++, and any C++ developer that doesn't use the STL will get confused looks from a lot of other developers who use the C++ standard template library because it is the standard. It's called standard for a reason. There's teams of there's an entire committee that decides what belongs in the standard and what doesn't. So for sort to even get here, there was a long discussion about what it should require in order to sort things, what its performance guarantee would be. So if you go to the C++ standard template library documentation, it will tell you this algorithm provides a very strict guarantee of n log n complexity, and in no circumstance will it ever exceed this. If it does, it's a bug, and they will fix it. There's many different types of implementations. I'm only talking about the Microsoft implementation currently, but there's GCC, Clang, LLVM, and many others. I lost my train of thought there, so give me a moment. Yes, I was talking about why you should use the STL. Now, if we bring it back to orthodox C++, we run into this dilemma where you want to avoid using the STL as much as possible. And for the sake of argument, let's assume that that's what you should do. How would you implement something like this? Do you say that it's okay to run a sort? You would be running a sort on not a standard container, presumably, because you don't need to use a standard container when you can use a C array. So how would you provide the information to sort in order to actually sort the array? Because in a C array, you don't have access to v.begin and v.end. You can't ask the compiler, oh, where is the first element in this array? Where is one past the last element? That's not something that you can do in a standard array in C. So how do you do this? I'm not sure. Part of my argument against this way of writing C++ is that it will confuse people and it doesn't really make a lot of practical sense. I do agree with the point that your program should be as simple as possible, and you can definitely overcomplicate things. For instance, instead of doing this, I could do a standard for each. And this syntax is quite jarring to look at, and it looks something a little bit like this. Although you totally can do this, and in the standard, there is actually a bit about using this sort of syntax over a regular syntax, but you run into things like lambdas, and maybe you're including the functional library now. Some of this can get complicated. I can understand why maybe you wouldn't want to do this. Although, again, if it's part of the standard, you should use it. It's part of the standard for a reason. A committee of people determine what's in the standard every year. They have a meeting. Their opinions are completely unbiased. They don't get paid to do what they do. They're not representing individual companies. They just decide what they think is best. And something exciting that's coming in the standard is this form of syntax providing pointers or iterators is no longer going to be required in the next standard. You can just provide the container itself. Now, in the current version of the MSVC STL that I'm running in the latest version of Visual Studio, you cannot do this, as sort requires two overloads, so a beginning and an end iterator. Although this syntax will be coming in C++ 23. And that will get it closer to higher level languages like Python, where this is how you would say sort, although you wouldn't include you wouldn't include the standard namespace. You would just pass in the container. And this is the exciting thing about the template library is it is evolving. It's really not this outdated thing, even though it's been around for a really long time. It is updating every single year. And they recently decided that we can figure out if it's a container or not. We can ask for its begin and end iterator behind the scenes. This is really all you need to see as a developer. There's no reason to see the beginning and end. You can do that if you want. That will still remain an option, but this syntax is clearly much cleaner than anything else. And with that, I am running out of time for today. So I want to thank everyone for coming. And if there's any other questions that you would like me to answer at this point, I can do so now. I hope all of you at least have some general sense about what STL is. Maybe you learned a little bit of C++. Maybe you didn't. Maybe you have some programming knowledge and want to try the C++ STL now. Maybe you've coded in Python or Lisp or something like that and would like to try C++. There will be a GitHub repository that I will be uploading on my GitHub page later today that will walk you through how to set up your environment in Visual Studio to run the C++ STL. I will also be uploading this video to my YouTube so that you can go back and view anything that I talked about today. I hope the information that I provided to you today was helpful. If there's anything that I can help with at this time, I will do so now. I see some hands raised. So if anyone would like to unmute themselves and ask a question at this point, now would be the time.
Sure. Hello. I don't know the name. Sorry, I joined late the meeting. I would like to know. Actually, I've done some C a couple of years ago, and I did some C++, but I didn't really like them. It was somehow hard for me. And I'd like to. I didn't really. I don't know really what was the today's. I mean, what you focus on today. I've just seen I've just when you explained you were explaining about the sorting algorithm. So the only thing I would like to ask if I'd like you to give me. I'm sorry because I joined late. So to give me a sum up on what you've been done, and also some recommendation about or resources on where to learn more about C++ and really have the basics on the language.
Yeah, absolutely. So today I talked about the C++ standard template library, which is what C++ adds over C, so more complex algorithms and higher level control. In terms of resources of how to learn about some of these containers and algorithms and general C++ things, Microsoft has excellent documentation on the C++ STL. And there are also a variety of books and videos. There is a lecture similar to what I've talked about today by Stefan T. Laue that you can find on Microsoft. I will pull up the links for that before we end today and put them in the chat so that you can check them out. There's books. Brown Stroustrup has an excellent book. He is the creator of C++, so his book is very excellent. It's called The C++ Programming Language. I personally own the 4th edition, which I believe is the latest edition, but I could be wrong. And before we end today, I will make sure to link all of that so that you can take a look. And
thank you so much.
Yeah, absolutely.
Good, thanks. Good evening, Brandon. Thanks for this interesting session about STL. But I have 2 questions from my side. I want to know what is the correlation between STL and Win32 APIs? And also another question that I have here, I just want to know, as STL is a own Microsoft implementation of C++, can we use STL to build application on others OS platforms such as Mac OS and so on?
Yeah, absolutely. So in terms of the Windows API, my understanding is that the STL is indeed cross-platform. Microsoft's implementation is specific to Windows, but it will run on any build of Windows, so 32, 64, 86. In terms of building the STL on other platforms, GCC supports Linux, Windows, and Mac. The Microsoft implementation is specific to Windows, and it's what I showed today, but most of them are extremely similar in their syntax. If anything, they're exactly identical. The implementation will vary slightly, but yes, you can use the STL on any platform you would like. You will just have to choose a compiler different from the one that I showed today in Visual Studio that is not developed and maintained by Microsoft.
Okay, so behind the scenes, if I get you all, behind the scenes, STL is separated from Windows APIs. That's it.
I don't think I understand your question.
So behind the scenes, if I get you all, STL don't include Windows API in it.
Oh, yes, I understand. Okay. Yes, the STL is separate from Windows APIs. So headers like Windows are separate from the STL. Although you can use the STL in tandem with these things. That's kind of how the STL is written. But yes, the STL does not really care about certain APIs like the Windows API. It is compiled separately and is not dependent on those things.
Ah, okay, thanks, good.
All right, I will wait and see if there's any more questions.
Hi, Brandon. Brandon, can you hear me? Yeah.
Yep.
Thank you for your event. It is very, very good. And I know now people are able to do things with C++ and STL. But I know we have new people here from other countries, and just to present what is happening now, we are students, Microsoft Learning Student Ambassadors, and Brandon is now Alpha. He is expecting to go to beta milestone, and I think things will be better. But it is also an occasion to invite other people to join the program. If we go to the website of the Microsoft Learning Student Ambassadors, we are going to see now application is ongoing now if people want to join, and then they will know how it feels better to be member of this program. But I want to thank you for your first event in the program. I think you achieved it, and people are enjoying what you have to learn, to teach them. And they can, I think, from their side, they are saying thank you. Thank you, Brandon.
Absolutely. I see another question.
I don't
I
know
was
if
muted.
there is someone
By
who
the
has a question.
yeah.
Yes, go
By the way,
ahead.
I have a question. I have a question on the application. I don't know actually how long does it take to so that they may give you the feedback on the application, because I've been applied since May, and I've done it again in June, in July, and till now when I look at the application, they are writing that my application is under review. I don't know how long does it take to give you feedback on the application.
Now what is written is application is under review. If it is under
Exactly.
review, I think they should give the next quote in this month. Before
right.
the end of this month, we
Thank
have
you.
to know who will be accepted or not. If not, if you are not accepted after that, they are going to say no, the application has not been is not accepted.
Okay, if there's no other questions, I'm going to put some links to different resources in the chat for additional things about the C++ STL. If anyone has any additional questions, I will be here for a few minutes after the meeting. As long as there are people here to ask questions, I will be here. I hope the information that I provided to you today was useful in some way. Like I said, I will be putting up a GitHub repository on my GitHub page later today that will walk you through how to set up the Visual Studio environment so that you can compile C++ using the MSVC STL. As well, I will have lots of links to different resources on that page also, as well as the examples that I've walked through today and some additional more advanced examples. So I'm going to grab some of these links. While I do that, if anyone has any questions, feel free to ask now. If not, that is all that I have for you today. I appreciate everyone that decided that this information was worth their time. Do we have another question?
Yes, Brown, I think it is okay now. People have done with questions. If you have something to share, then you can go and then we can stop our meeting. I think we have at least how many minutes? Now 3 minutes left.
And Albert, sorry, I have another question. I get a little
Yes.
question.
Yes.
I
Yes.
just
Yes,
want to
Dan.
know what is the next event Brandon has planned to for in this program?
The
Brown,
answer to
it
that
is your
is I
question.
do not know.
It is your question. You can answer it. But I know you have a
Okay.
path you are following. You know we are going to plan
Yeah.
another event.
I really enjoyed
I
this
think it.
session.
Yes.
I
You
really
say.
enjoyed this session, and I hope that you still bring something more on Visual C++. It's very interesting because it is a subject that many students doesn't know exactly for actually. So it will be interesting to stay in this way to have more events on Visual C++. It will be very interesting.
Yes, I think it
Yeah.
is. It is good. He knows
Yeah.
many things in that platform, and he's going to continue with the same. It is not the last event. This is the first, not the last. And he's
Yeah.
new in the program. We know that many things are going to happen after.
Yeah, that's right.
Yeah. Yes, Ash, you can go.
All right. Actually, I've been hearing you saying Visual Plus Plus all the time. Is there a difference between Visual Plus Plus and C Plus Plus?
The original
I
plus
don't
plus, as
feel.
Brandon said.
Yeah. So the Visual C++ is just what the specific Microsoft implementation is. So it's the Microsoft Visual C++ standard template library. In other applications, I believe it's just called the C++ standard template library. I believe that naming scheme is specific to Microsoft, and I'm not confident on the exact reason why it's called what it is. So I don't feel particularly equipped to answer that question.
You mean, generally speaking, they are the same?
Yes, in general, that naming difference doesn't impact the differences between the different standard libraries.
All right, thank you.
Yeah, all of the standard libraries are maintained by the same standard. So the example that I showed today of sort and vector will be identical on different implementations of the library. They all fall under the same syntax standards and performance standards. So in terms of other resources, Stefan Tilawe has an excellent walkthrough of the standard template library. He's been maintaining it for a very long time. Here is the link to this page. I would also like to link the standard template library Microsoft GitHub page. The standard template library, as of a few years ago, or maybe even sooner than that, I'm not confident on the time frame, is now completely open source. So if you feel compelled to learn more about this C++ STL, look at what's going on behind the scenes, they have everything open source. You can make contributions however you want to do it. They also have a Discord server where they are extremely active in talking about future development, and they have an entire channel on the Discord server dedicated to getting people started with the STL, whether that's developing it or getting everything running in Visual Studio. So that as well as an excellent reference. I would also like to link the documentation for the STL. Microsoft has fantastic documentation on the STL. They also have documentation walking through certain features of the C++ itself. So syntax things, templates, everything like that. Like I mentioned, there's also books. Books on C++ specifically, like as a language. There's also books on the STL. So if anyone prefers to read rather than watch, you can obviously read the official documentation from Microsoft. There's also books that you can buy. Some of them are free, some of them cost more than they should, but that is always an option. So if there's no more questions, that's all I have for you today. I will stop the recording now.